So we're going to do this exactly like we did our other transformations. Talk about what it is, how we describe it, kind of technically, and then what it tells us to do. So a dilation. Before we write down a definition, what do we think it's going to mean? Make it bigger. When we talk about our pupils dilating, they get bigger. So dilation has to do with bigger. So our object doesn't stay the same size anymore. We're not talking about a rigid transformation. So dilations have what we call a center of dilation. A center of dilation. So when our eyes dilate, our center of our eye is the center of dilation. Center of dilation is a point C. And a scale factor N. We're making something bigger, so we need something to tell us how much bigger. And we're going to say N is positive. We don't do negative dilations. N is greater than 0 is a transformation. And notice we didn't say rigid transformation, where several things happen. And before we go on, let's try to remember anyway. We talked about scale factor before. What were we doing what were we studying when we talked about scale factor before? You remember? Had to do with shapes, just like dilation. Shapes were bigger or smaller than each other. Similarity. We talked about similarity, and we talked about scale factor with similarity. We made a ratio of the sides of the similar figures, and we had the scale factor. So when we do dilations, we get similar figures rather than congruent figures. All right, so with the dilation, the center is its own image. So C equals C prime. So if we do a dilation and we have an object that's on the center of dilation, the image of that point stays the same. Just like something that was on the center of rotation is its own image, and just like something that was on the mirror line is its own image. For any other point, P, the image P prime is on the ray CP. And we'll draw a picture, and this will make a little more sense when we draw our picture. We draw a ray from the center to our point, and we extend that out. The image point is on that ray. The length of CP prime is N times the length of CP. So we multiply our length by the scale factor. That's what we're saying. So we could write a little note here. Lengths are multiplied by the scale factor. And that's exactly what we did when we talked about similarity. Is when we had a scale factor of 2, the second object was twice as big as the first object. We multiplied the length by the scale factor. So what we're saying here is dilations preserve angle measure. The angles stay the same. But they do not preserve length. we end up with a similar picture. So let's draw a picture of what all this means. So here's my center of dilation, C. And we're going to dilate this triangle. So let's call this triangle X, Y, and Z. If we had a point on our object that was at the center of dilation, after we dilated, it wouldn't move. So C would be C prime. This bit about the ray. So what we're going to do is draw a ray out from C through X, and our image point is going to be on that ray. So let's say X prime is there. And what I'm doing here is I'm making this approximately 3. So if I look at the length of this, this is about twice as long. So this would be a scale factor of 3, about. I'm doing it kind of by eye here. I'm going to draw a ray through Y. And Y prime is going to be out here. So I did kind of one of those, 2 of those, 3 of those, approximately. And then we'll do one for Z. We'll do a ray through there. And there's 1, there's 2, and Z prime is approximately, I'm just doing it by eye here. So there would be my new, I'm going to do that in a solid line, on a dotted line, that would be my new triangle. So that's my dilation. This is what this means, that the image point is on this ray. I just extend this line through this vertex, and my image point is on that ray. And the length from C to X prime would be n times the length from C to X, so whatever our scale factor is. This is approximately a scale factor of 3. And if we looked at the lengths of the sides of the triangles, X prime, Y prime equals n, our scale factor, times XY. Whatever our scale factor would be. So here it's about 3 times as big. What's that? N XY. So we can find the scale factor by taking the length of the image, a length on the image, and dividing it by the length on the pre-image. So when we're doing this, we always put the image on top, the image length. So just like we did with similarity, we say this one is 3 times as big as the other one. The scale factor is 3. And these 2 triangles would be similar. And I know I didn't do the drawing perfectly, but we'll do an example next where we actually measure it out to come up with a dilation. All right, questions there? Okay, let's actually do one where we do some measuring, but we'll just dilate a segment. Yep. All right, so let's say we want to dilate a segment with a scale factor of 2. So I'm going to say center C, scale factor 2. So here's C. And here's segment AB. And I want to dilate that. And this is my center of dilation. I kind of think of the center of dilation as like where the the light, the bulb of the projector is. We're kind of shining a light on this thing. All right, so I'm going to, in order to do my dilation, I'm going to draw my ray. There's a ray through C and B, and there's a ray through C and A. And to make sure I get my scale factor of 2, I need to grab my ruler. I'm going to grab my ruler, and I measure. So I'm going to measure from C to B. Is about 1 3/4 inches. So I need my image point to be twice as far. So it needs to be about 1 3/4 inches from B. I need to extend my ray a little bit here, because I didn't make it quite long enough. So then my point here is going to go right there, right where the W is. So there's my point. So there's going to be B prime. And then I do the same thing for A. I'm going to measure that distance. I put my ruler there, and I measure that, and that's just a little more than 1 1/4. And I'm going to measure that same distance from A, no more than 1 1/4, so about there. There's my point. So there would be A prime. And I connect those. And there's my dilation. And my scale factor would be 2. If I measured AB and I measured A prime B prime should be twice as long. This length from C to B prime should be twice as long as the distance from C to B. That's why we measure the same distance. If it was supposed to be a scale factor of 3, we'd want to make it 3 times as long. So we would have measured out another length that was the same length. So that's how we can dilate with any scale factor we want. And we can make our center of dilation anywhere we want. All right, questions about what we did there? All right, if n is greater than 1, so our scale factor is bigger than 1, we call the dilation an enlargement. And if n is between 0 and 1, so that means we have some kind of fraction or decimal, 1/2, 1/4, 0.7, we get a reduction. We call it a reduction. So that's just how we refer to dilation. It makes something bigger, make something smaller. So we can dilate something, make it larger, dilate something, make it smaller. Now, just like we talked about yesterday with the rotations, where we did the one rotation where we measured all the angles, and we decided that would be kind of tedious to have to measure all the angles to rotate our figure. Well, there's a shortcut for dilations also. In our book, all of the dilations will have 0, 0 at the center. So the origin is our center. This makes it really easy to do our dilation. When that is the case, we can multiply any point x, y by the scale factor. So if we use 0, 0, if we use the origin as our center of dilation, all we have to do to get the coordinates of our new point is multiply the point by the scale factor. So for example, if we wanted to find dilation of 3, 3, 5, D tells us to do a dilation. Three tells us that scale factor equals 3. So this is how we write a dilation. Dilation, scale factor of 3. When we write it like this, we're assuming that we're dilating, our center of dilation is the origin. We just multiply each one of these by 3. 9, 15. And that's all we have to do. We can make any scale factor, and all we have to do is multiply our points by the scale factor to do a dilation. So in your project, the project asked you to do the dilation with the center excuse me, at 0, 0. So you decide your scale factor. You want your scale factor to be 3. You take all of your points that you're going to dilate and multiply them by 3. And write those in your little charts for your new coordinates. And then on the piece of graph paper that I gave you today, that's where you're going to do your dilation because it's going to be bigger. Then you plot those points and you have a dilation of your figure. That's all you have to do. For the original image, right. All right, are we good there? Okay, I have a couple of questions for you now. Let's say I drew this triangle, or these triangles. Change color. All right, there are my triangles, and I'm going to say this is A, B, and C, and this is A prime, B prime, and C prime. And I'm going to say I'm going to tell you this is a dilation. So is D by some scale factor of triangle ABC an enlargement or a reduction? So I'm dilating triangle ABC and I'm getting triangle A prime, B prime, C prime. Is that an enlargement or a reduction? Reduction. Why is it a reduction? Smaller, right? Reduction. I'm going to say triangle A prime, B prime, B prime, C prime is smaller. All right, now we're going to add something here. I'm going to say A is 0.40. C is 0.2 negative 4. D is 0.04. A prime is the 0.20. C prime is the 0.1 negative 2. And B prime is the 0.02. Now I'm going to say, what is N? What is the scale factor? Almost, not negative 2. What do we multiply the coordinates by? This coordinate to get that coordinate? 1/2. N equals 1/2. I multiply the coordinates here by 1/2 and I get the coordinates here. Multiply the coordinates here by 1/2 and I get the coordinates here. Multiply this by 1/2 and I get the coordinates there. So the scale factor is 1/2. So we've shrunk that triangle by 1/2. If I were going the other way, what if the image, the pre-image, was A prime, B prime, C prime? and then the dilation takes me to A, B, C. What would the scale factor be then? 2. So 1/2 makes it smaller, 2 makes it bigger. Questions on that example? Dilations with the center at the origin are really nice, really easy. What if we had a 4x5 photo? And we want to enlarge it by a scale factor of 1.25. How big is a new photo? How big would the new photo be? How would we figure it out? Multiply everything by 1.25. That's a scale factor tells us multiply these things by 1.25. So 4 times 1.25 is what? 5. And 5 by 1.25 equals 6.25. So the new photo is 5 by 6.25. Hmm?
So how you said like it's 0, 0. So is that we have like graphs that it matters about like you said you can always multiply it by the scale factor, and then we're doing that here. So is it just like with graphs it's not always like that, or you do it here?
So when we enlarge by a scale factor, it doesn't matter where the center of dilation is. The scale factor tells us how much bigger the image is going to be.
So then why did you say like things like 0, 0
So when you're doing your homework problems, they'll say dilate this figure, and when they say that, they mean use the origin as the center of dilation. Or they'll say this figure is a dilation, blah, 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 and you're assuming that the center of dilation is 0, 0. Because if I gave you, for example, if I just gave you a picture, and I said, dilate that segment, without knowing where the center of dilation, I could make the center of dilation here, here, here. I can make it on this end of the segment. If you didn't know, then you wouldn't be able to do it. So in the book, if they say dilate that segment, you're just assuming that the center of dilation is 0, 0. Okay? Just to make things easier. All right, last example. What if I had 2 segments, like so, and I said that this was AB, and this was B prime, A prime, and I said find the center of dilation. How would we go about finding the center of dilation? If I knew that one of these was a dilation of the other, what would I do to find the center? Right, draw your rays that connect your image and your pre-image points. So, like so. There's the ray that goes through B and B prime. There's the ray that goes through A and A prime. There's the center of dilation. So you just kind of do the reverse of what we did on the first problem where we drew the dilation. We're kind of drawing the rays backwards to find the center of dilation. So you draw your rays. So you'll have a couple of questions like that. All right, questions? Homework page All right, there's that.